This is Algebra 1A, Lesson 1-8, Interpreting Graphs of Functions. The objectives are represent relations and interpret graphs of relations. Y-intercept, the y-coordinate of a point where a graph crosses the y-axis. X-intercept, the x-coordinate of a point where a graph crosses the x-axis. Line symmetry, a geometric property of figures that can be folded and each half matches the other exactly. Positive, a function is positive on a portion of its domain where a graph lies above the x-axis. Negative, a function is negative on a portion of its domain where a graph lies below the x-axis. Now I'd like for you to find your handout, Interpreting Graphs of Functions. This first graph I'd like for you to go ahead and make. Stop the video, make your number lines count by ones from -3 to 3 for the x-axis and -4 to 4 for the y-axis, and then copy what I have for the function. Now that you've created your graph, let's talk about what each of these different interpretations are as it relates to this graph. By definition, the x-intercept was where does our function cross the x-axis? And if you look, it appears that it crosses at -1. Y-intercept, by definition, where does our function cross the y-axis? And it is at 2. Increasing, by definition, where is the function rising? And we have to talk about that in terms of the x-axis. So, if you look at the whole thing, it looks like it is all rising. Decreasing, where is our function going down? There's nowhere that it's going down. Where is it positive? In other words, where is it above the x-axis? And if we describe it using our numbers on our x-axis, it's above the x-axis beginning at -1. And if we go all the way across, it stops at about 2. So this area right in here is above the x-axis. So we call this -1 to 2. Now we look at the area below the x-axis. And it looks like a good estimate would be between -3 and -1 is where we're falling below the x-axis. Go ahead and draw this graph. We're counting by 2's on the x-axis from -6 to 6 and on the y-axis from -8 to 8, and draw your function. Okay, first of all, we're going to talk about the x-intercepts. Sometimes there can be more than one place that our function crosses the x-axis. And if you look at your function, it looks like it touches the x-axis at -4 and 4. Now, the y-intercept. Where does it cross the y-axis? I believe that's at 8. Next, we have increasing. From where to where is our function increasing? Well, it looks like it's increasing from here to here. We use the numbers on our x-axis to describe where is that increasing taking place. It looks like in the area of -6 all the way over to 0. So -6 to 0. Now we need to figure out where is it decreasing. Again, we use our x numbers to show the area that it is decreasing. And if we match that up on our x-axis, it looks like from 0 to 6. Do we have any relative extrema? Relative extrema would be a very tall mountain or peak in our function, which would be a relative maximum. And we would describe where that's at according to our x values. Or we could have a relative minimum, which would be like a valley or a ditch. It has to go up and then down. It can't just go straight up and stop there. That would not be a relative maximum. It could not just go down and stop there. That would not be a relative minimum. It has to actually make a peak or a valley. So, do we see a relative maximum or a relative minimum? And we do. We have this peak, and we use our x values to read it. Where is it happening? It's happening right here in this area, so our x value is 0. Now let's look at where is this positive? Where on the x-axis do we see the function above? And use your x values to talk about that. It's above in this area right here, which is between -4 and 4. And where is it below? Looks like it's below in 2 places. So describe both of them. According to your x values, this would be between -6 and -4, and another place between 4 and 6. So that's how you interpret what's going on with a function on a graph. Now let's turn the page and look at example 1 in your notes. Height of a golf ball. You should have a graph similar to what I have here. I apologize that things got blurry there, but I think we can do this. So first of all, we need to identify the function as linear or nonlinear. What does nonlinear mean by definition? It is not a straight line. Linear, by definition, means it is a straight line. So what do we have here? We have a nonlinear function. Is there any line symmetry? By definition, line symmetry was you could draw a folded line, and if you were to imagine it folded, that each half would match the other exactly. So, if I were to fold this line right here, each side would match exactly. You can describe symmetry of where does it cross the x-axis. So there could be a line of symmetry when x equals 60. Now let's talk where it's positive. Where does it lie above the x-axis? And I believe all of this is above the x-axis. Negative, where does it lie below? None. Increasing, from where to where is it increasing? 0 to this area right in here, 60. And decreasing would be this area right here. Use your x values to represent it. So 60 to 120. Is there any extrema? Do we have a peak or a valley? We do. Remember to use your x values to describe it, and it happens at 60. Now let's go across the page to David's savings for car. First of all, is it linear or nonlinear? This appears to be a straight line, so I would say it's linear. Do we have a place where we could put a fold in this function and one side would match the other? Is there symmetry? The answer would be there's none. Where is it positive? Where does it lie above the x-axis? And it looks like it all lies above the x-axis. Therefore, none of it would lie below. Where is it increasing? Again, it looks like all of it's increasing and none of it's decreasing. And extrema, do we have a valley or do we have a peak? And if so, where is it on the x-axis? Does not appear that we have either one. Now let's go back down to the bottom left of your notes, solar reflector. And yours should look like this. Is this linear or nonlinear? Appears to be nonlinear. It does not make a straight line. Could we draw a line of symmetry and put a fold there? And imagine if we fold it, it would look the same on both sides. I believe that line of symmetry would be like right in here. According to your x values, where is that at? Where is this on your x-axis? That would be at 0. Where is it positive? Where is it lying above the x-axis? Well, if you look at this piece right here, that's like from -16 to -12. And I believe we have a second piece over here, 12 to 16. Where does it lie below? This area right in here is below, and that's -12 to 12. And where is it increasing? I believe this section of our function is increasing. So according to our x values, it starts at the 0 area and goes all the way to 16. And I think we need to look at our decreasing. Where is it going down? Again, use your x values from 16 to 0. Actually, -16 to 0. Do we have any extrema? I believe we have a valley right here. Remember to use your x values to describe where that valley is, and it is at x when it is 0. And one more, baking supplies. Do we have a function that is linear or nonlinear? I believe it is a straight line. Straight lines, unless they're horizontal, will not have any symmetry. So we can say none. Where is it positive? Where does it lie above the x-axis? I believe that is all. Or you could actually say from 0 to 10 if you wanted. That would be a good description. Where is it negative? Below the x-axis would be none. Increasing, I don't believe the cups of flour is going to increase as we make our cookies, so this is none. Decreasing would be all, or again, you could describe it as 0 to 10. And do we have any extrema? Do we have any peaks or do we have any valleys? And again, there is none. That's all for these notes. You will have an assignment that goes with it.